Hello students, grade 8 mathematics linear equations in one variable part 1. Here we will be recapitulating whatever we have learned in grade 7. Definition: linear equation is an equation which contains only one variable and has degree 1. For example, x plus 5 is equal to 10. Here x is a variable with degree 1, that is the power is 1. Moreover, these equations are called linear because when we draw their graphs we get straight lines. Let us consider one interesting example. We can visualize linear equations. Linear equations are actually mathematical balances. Imagine a weighing balance in which there are 10 marbles on one side and there are only 5 marbles. A person asks you, how many more marbles should I put here so that we have a balance? What will you do? You will start putting marbles one by one till the balance is created. This is what is finding the value of variable. Let us see. If I had represented this equation as x plus 5 is equal to 10, that means how many more marbles should I put into x so that into 5 so that I have 10 marbles, right? And then by experimentation I got that I should put 5 marbles to get the balance. Now we should know how to solve them mathematically. Some of the things we have learned in 7th grade. Let's see. Now if this is an equation, we learned in 7th class that if it is an equation, then whatever I will add here, I will have to add here to maintain the balance. Whatever I have to subtract, I have to subtract here also so that the balance remains. Means if I have to pick out 5 marbles from here, then I have to pick out 5 also from here. 10 were here, 10 were here, balance is there, right? If I am taking out 5 marbles from here, then I need to pick out 5 from here so that the balance remains. So mathematically we can say that we can add, subtract, multiply or divide by the same number on both sides so that the balance is maintained. For example, if I have x plus 5 is equal to 10, from this side if I am subtracting 5, I need to subtract from here also 5. This was one of the methods that we learned last year to find out the value of the variable. Again, 5x is equal to 35. So I want to have x here, right? So that means I will be dividing here by 5. If I divide this side by 5, I need to divide here also so that the balance of the equation does not change. So 5x divided by 5 will be equal to 35 divided by 5, which gives me x is equal to 7. This was one of the method that we learned. Now we learned one more method, that was method of transposition. What was that? In that method we used to bring variables on one side and the constant terms on the other side. So x plus 5 is equal to 10 can be solved by this also, that is x is equal to 10 minus 5. I bring this constant term on the other side and I get x is equal to 5. Let's take one more example. X minus 7 is equal to 13, which implies x is equal to 13 plus 7, which implies x is equal to 20. One more example, 2x is equal to 14. So here 2 is multiplied by x. When I will be transferring it on the other side, I will be dividing it. Here it is in the numerator. When it goes there, it will go in the denominator. So that means x will be equal to 14 upon 2. Cancel it, you get 7. That means x is equal to 7 is the answer. Let's consider one example of division. X upon 7 is equal to 5. So I will be bringing this 7 that side. It is here in the denominator. When it moves to the other side, then it will go in the numerator. In other words, here it is dividing. So when it will go there, it will multiply, right? Division and multiplication are reciprocals of each other. They are in opposites of each other. So this implies x is equal to 5 into 7, which implies x is equal to 35. There's one more example which will involve two operations. For example, I have 5x minus 2 is equal to 7. Here this is subtracted and here it is multiplied. So I have to handle two operations. But I can handle one operation at a time. So first I will handle the subtraction. So I take it on the other side and it becomes 5x is equal to 7 plus 2. This implies 5x is equal to 9. Now this 5 has to be brought here. Here it is multiplied. So here definitely it will be divided. So x will be equal to 9 divided by 5. This is the answer. Now few things to remember. In transposition method, the operation changes when a number is transposed from one side to the other side of equality. That is, addition changes to subtraction, subtraction changes to addition, multiplication changes to division, and division changes to multiplication. Now, let us consider some examples from exercise 2.1. One example that I have taken is 5t minus 3 is equal to 3t minus 5. I notice here that variable is on both the sides. So I will adopt this technique that I will bring all the variables on one side and all the constant terms on the other side. So 3t will be brought here. When I bring 3t here, here it is positive. So when it comes here, its sign will be changed. 5t minus 3t is equal to minus 5 remains here, and when minus 3 will go there, its sign will change. So this gives me 2t is equal to minus 2, which implies t will be equal to minus 2 upon 2. Cancel and I get t is equal to minus 1 as the answer. Question number 2. 8x plus 4 is equal to 3 times x minus 1. Here you see 3 is multiplied by x minus 1. So what was the method? That 3 will be multiplied with both. Which property is this? This is the property of distributivity. That is, multiplication distributes over subtraction. 8x plus 4 is equal to 3 times x minus 1, which means 8x plus 4 is equal to 3x minus 3. This implies 8x minus 3x is equal to minus 3 minus 4. When it goes there, sign will change. So this gives me 5x is equal to minus 7, or x is equal to minus 7 upon 5. Example number 8. That is 2y plus 5 upon 3 is equal to 26 upon 3 minus y. Again here I have numbers in the form of p upon q. So I will have a little difficulty in solving, but it doesn't matter. We know how we can handle these kind of numbers. So 2x plus y is equal to 26 upon 3 minus 5 upon 3. So don't worry, what will we do? Here 3 is the common denominator. So 3x is equal to 26 minus 5 upon 3, because denominator is same. So numerators will be subtracted directly. So this implies 3y is equal to 21 upon 3. Cancel, you get 7. So this implies y is equal to 7 upon 3. So after this you will be able to do exercise 2.1 of NCERT very easily. Now some questions based on exercise 2.5. 2.3 also can be handled easily after knowing these methods. Now some examples from exercise 2.5. First one, x upon 2 minus 1 upon 5 is equal to x upon 3 plus 1 upon 4. So again here I will bring x minus 2 minus x upon 3 is equal to 1 upon 4 plus 1 upon 5. So taking the LCM, 6 here. So divide 6 by 2, you get 3. 3 into this, 3x. From here you get 2. 2 into x, 2x. 3x minus 2x upon 6 is equal to 20 here, and here you have just taken the butterfly method. That's possible. 20, this into this, 5 into 1 plus 4 into 1. So this implies x upon 6 is equal to 5 plus 4 upon 20, which implies x is equal to 9 upon 20 into 6, which gives me 27 upon 10. Let's take one more example which is very easy. X minus 5 upon 3 is equal to x minus 3 upon 5. This is very easy to handle, just cross multiply. 5 into x minus 5 is equal to 3 into x minus 3. This implies 5x minus 25 is equal to 3x minus 9. This implies 5x minus 3x is equal to minus 9 plus 25, which implies 2x is equal to 16. This implies x is equal to 8. Answer. One more example. 3t minus 2 upon 4 minus 2t plus 3 upon 3 is equal to 2 upon 3 minus t. Notice carefully, I will bring t on this side. So this implies 3t minus 2 upon 4 minus 2t plus 3 upon 3 plus t upon 1 is equal to 2 upon 3. I can take out the LCM of these and solve it combined in a combined form, right? So LCM of 4, 3 and 1 will be 12. And now here this bar, this upon sign, this acts as a bracket. This is very, very important because here it is a minus sign. So this minus sign is associated with 2t plus 3 together. So we have to be very careful while solving it. LCM is 12. So I divide 12 by 4. I get 3. That 3 will be multiplied by 3t minus 2. Again divide 12 by 3. You get 4. 4 will be multiplied by 2t plus 3 plus 1 divides this 12. 12 into t is equal to 2 upon 3. This implies